Okay, so this is day 2 of 4.2 notes, slopes of parallel and perpendicular lines. So we've already learned what parallel lines are. Parallel lines are lines that never touch, the same distance apart all the time. Perpendicular lines are lines that intersect at a 90-degree angle. So now we're going to look at what are the slopes of parallel lines compared to each other, and what are the slopes of perpendicular lines compared to each other. So it says lines in the same plane that do not intersect are parallel lines. Non-vertical parallel lines always have the same slope. So parallel lines have the same slope. Okay? So if I find the slope on this line compared to the other line, they should be the exact same. So this is the equation y equals 1/2 x plus 3, and this is the equation y equals 1/2 x minus 1. Okay, so if you look at it, this is a slope of 1/2, and this is a slope of 1/2. I can see from the equation, but I can also count. So if I go from point, I go up 1 and over 2. From this point here, I go up 1 and over 2. So both of them have a slope of 1/2. So it says to find the slope of each line to the left, and it wants to know which ones are parallel. So I'm going to count up. I go up 1, 2, 3, 4, and over 1. So this one has a slope of 1. It's slanted in the positive direction, so it is a positive slope. On this one, I'm going to go up 1, 2, 3, 4, 5, and over 1. So this has a slope of 5 over 1, or just 5 over 1, which is 5. Sorry, in the first one, it should be 4 over 1, which is 4. And then the last one here, I'm going up 1, 2, 3, 4, and over 1. So the slope is 4 over 1, or 4. So are any of them parallel? Yep, we can say that this one and this one is parallel. Okay. Which of these lines are parallel? How do we know? Okay. So let's count. We're going up 1, 2, 3, and over 1, which means the slope of this one is 3 over 1, or just 3. For the next one, I'm going up 1, 2, 3, and over 1. So the slope is 3 over 1, or just 3. And this one, I'm going up 1, 2, 3, 4, and over 1. So this one is a slope of 4 over 1, or just 4. Now, all of these are slanted in the negative direction. So let's go back and make sure that we say all of these are negative slopes. So which of them are parallel? We would say that this line and this line are parallel to each other because they have the same slope. All right, let's go ahead and have you try number 2, pause the video, and then come back and check and see how you did. All right, so the slope of this one, 1, 2, 3, 4, 5, and over 1, 2, 3. So this is a slope of 5 over 3. Up 1, 2, 3, 4, and over 1, 2, 3. So this is a slope of 4 over 3. And the last one, up 1, 2, 3, 4, and over 1, 2, 3. So we can see that these two are parallel because they have the same slope. All right, so the next one, we have y equals -5 and y equals 3. Well, you remember if we have just y equals a number, it was always going to be a horizontal line. So y equals 3 is going to be somewhere around here. Y equals -5 would be somewhere down here. So are they parallel? Yes, because they're both horizontal lines, so they're going to have the same slope. Both of them are going to have a slope of 0. So on this one, y equals 0 would look like this. X equals 0 would look like this. It's our vertical line. Are those parallel? No. One has a slope of 0. The other one has a slope that's undefined. And the last one, x equals -4 would be down here, and x equals 1 would be up here. Are they parallel? Yes. They both have an undefined slope. Okay. So now let's look at perpendicular lines. Lines in the same plane that intersect at a right angle are perpendicular lines. Two non-vertical lines are perpendicular when their product of the slope is 1. So when you multiply their two slopes together, slope of the first one times the slope of the second one, it has to equal 1. That's how we know that they're going to be perpendicular, which means that perpendicular, that's the abbreviation, it looks like an upside down capital T, perpendicular lines have opposite reciprocal slopes. So for example, if I have one of them that has a slope of 3 over 2, the opposite reciprocal of that would be a negative 2 over 3. Opposite means change the sign, and reciprocal means to flip-flop the numerator and the denominator. So if one has a slope of 3 halves, the other one has a slope of negative 2/3, we would know that they are perpendicular to each other, because if I multiply those two together, 3 over 2 times negative 2 over 3, that gives me negative 6 over 6, which would give me negative 1. It has to be equal to negative 1. Sorry, that was cut off there. Make sure you make that addition. Okay, so they always have to be equal to negative 1 because they have to be opposite reciprocals to each other. Okay, all right, so we are going to take a look at some more of them and see whether they are parallel, perpendicular, or it could still be neither. So let's start by finding the slopes of them. So this one, I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2. So this is a slope of 8 over 2, which reduces to 4. This one, I'm going up 1, 2, and over 1, 2, 3, 4, 5, 6. So this one has a slope of negative 2 over 6, which is negative 1/3. And the last one, I'm going up 1, 2, and over 1, 2, let's see, 1, 2, 3, 1, 2, and over 1, 2, 3, 4, 5. So this would be a negative 2 over 5. Okay, are any of them parallel or any of them perpendicular? No. None of the slopes are the same. None of the slopes are negative reciprocals of each other. So none of them are going to be parallel or perpendicular. Okay, go ahead and try number 7 and 8. Pause the video, come back and check and see how you did. Okay, so for this one, let's see. I'm going to go up 1 and over 1, 2, 3, 4, 5, 6. So this one has a slope of negative 1 over 6. Okay, the next one, I'm going up 1, 2, 3, 4, 5, 6, and over 1. So this one has a slope of 6 over 1, or just 6. Either way is okay to write it. And the last one, I'm going up 1, 2, 3, 4, 5, 6, 7, and over 1. So this would be a slope of 7 over 1, or just 7. So we can see that this line and this one are perpendicular to each other. They have opposite reciprocal slopes. 1, 6, and 6 over 1. One's positive and one's negative. And number 8. I'm going up 1, 2, and over 1, 2, 3, 4. So that means my slope is 2 over 4, which is 1/2, and it is negative. Okay. My next one, I'm going up 1, 2, and over 1, 2, 3, 4. So my slope of this one is 2 over 4, 1/2, and again, it is negative. And the last one, let's see, I am going up 1, 2, 3, 4, 5, and over 1. So the slope on this one is 5 over 1, or just 5. So you can see none of them are perpendicular, but these two are parallel. None perpendicular. Okay. All right, last ones. Are any of them perpendicular? Explain how you would know. Anytime you have an x equals a number and a y equals a number, those are always going to be perpendicular, because x equals negative 2, would be your line that looks like this, and y equals 8 would be somewhere up here, you can see that they are going to have perpendicular intersection. One is a slope of 0, one has an undefined slope, so they are perpendicular. On the next one, they're both x equals numbers. If they're both x equals numbers, x equals -8, x equals 7, they're going to be parallel, so none are perpendicular. And on the last one, you have a y equals 0 and an x equals 0. One looks like this, one looks like this. They will intersect at a 90-degree angle, so you can say, yes, they are perpendicular. All right, so we know parallel lines have the exact same slope. Perpendicular lines have negative reciprocal slopes. Being able to identify those either by counting on the graph, or you could use the formula for y2 minus y1 over x2 minus x1. That still works to identify their slopes. Once you've identified both their slopes, then you're just comparing them. Are they the exact same slope, or are they negative or opposite reciprocal? So one positive, one negative, and the flip-flop of each other. Write the summary in your own words, mark down anything you have questions on, and that's it for today.